Hello, welcome to our Geospatial Centroid training video on working with tables using Python pandas. What is pandas? Not these pandas, but rather this pandas, which is a Python library for the Python programming language designed to work with data and tables and do some basic analysis with your tables. In this video, in this demo, we will be using pandas to do a few basic things, and then there is a second pandas video where we'll get into a few more, slightly more advanced things. To get started, we're going to do everything in a notebook. So to get started, we'll have to open up a Jupyter notebook, and we'll take a look at the data before we begin. Here's the data that we'll be using. It's a really simple, small, short CSV with just a few columns for a station number. So these are precipitation gauges at the CSU Mountain Campus. Coordinate values for each precipitation gauge, and then just some summarized precipitation value in millimeters of how much precipitation was captured during that month. Each session is the span of 1 month. This is what the data looks like in Excel. What we're going to do now is go into a Jupyter notebook and access this table using Python and the pandas library and do a few things with it from there. To open up a Jupyter notebook, the way I open it up on my machine is using an Anaconda prompt. So I can switch to the folder that I need to launch my notebook from, and then I can launch my notebook. There are a number of ways to open up a Jupyter notebook. Using Anaconda Navigator or the Anaconda prompt is just one way. If you are in the ArcGIS world, there's also a way to open up a Jupyter notebook as an ArcGIS notebook through ArcGIS Pro and even ArcGIS Online if you have the right privileges. A notebook can be saved as a .ipynb file, and I already have one set up to be a framework for us to work through. And this is just another way to write code. Everything we're doing right now could also just as easily be done in PyCharm, Spider, or even idle. The key is that you need to have access to the file to work with and access to the library that you need. And pandas is a pretty basic library. You don't have to go out and install it. It comes with Python when you install Python. So here's what we'll be doing right here. First, let's access that CSV right in here. We'll have to import pandas, even though it's on my machine. We do have to import it first. So import pandas, and we'll give it a nickname, and we'll also import OS. Now let's specify the path to the data, and there are a number of ways you can do that. I'm just going to copy and paste my path here. So that's my path, but then I have my file name. And you can do this all together. You don't even need to make variables for this. I'm just kind of showing you how it can be done. If you have your path and file separate, then you can combine them pretty easily using os.path.join. Once you have that set up, then you want to read it in using the pandas method read_CSV. So what we want to do is create a data frame. Pandas, when you read in a CSV and you read it into memory, it becomes what's called a data frame, which is an array of your rows and columns. So it's just like a virtual version of your table. And then you can access the rows and columns separately and also the values. So I'll type df equals pd read_CSV. And then the name of the variable that is my data set, which I called data. You could also just put the path in here if you have that as well. Now let's run this cell and see that it read. Great. Once you have that CSV read into memory, you can look at it, use it, print it out, get to the data, get to the columns. We'll start off simple. We'll just do df.head, which is a way to print out the first 5 rows of your table. And since this cell will be doing multiple things in one cell, I will use print. All right, now there's a couple of ways to get the column names. Let's say you want to get the column names out. Oops, let's fix that. If you want to print out the column names, you can use df.columns. So you can get the columns with df.columns, and you can either print that out by looping through it with a for loop like we have here, or you can just print out the straight up list. And you'll see when we run this, it gives you something very different. So here is our df.head. Those are our first 5 rows. Here are the column names printed out one at a time from the for loop. And then here's what it looks like if we just print the list. And it looks like a list. It's not very well formatted, but it works. It lets us see the column names. As a side note, if you need to delete a column, there's a .drop function. And so there's a sample for it here. And you can delete columns if you have extraneous columns that you don't need. Now let's get into some basic statistics for the columns. There are a few ways to do this. You can call out one column and get individual statistics that you want, or you can use .describe and get all the statistics for all or one column at once. Let's say you just want to get the mean or average of one column. You could do something like this. Point to your data frame and do .mean on the data frame, and then pass in the name of the column as a string in square brackets. And what this will give you is your value. There are other ones as well, so let's hit enter and we can change this. So we can change it to min. We can change it to max. So you can play around with those and get the values that you need. Now, right now we're just getting the value by itself, but you might want to put this into some sort of better formatted result or report. And so let's take it one step further. All right, so here we have 2 things going on. First is that we're setting up some variables for the field name. Notice how up here we hard-coded the field name in, but you might want to make that more dynamic. You might have multiple fields that you want to loop through, and so you need to name it dynamically. So here we have the session number and then the base of the field name. So we're creating a dynamic field name. And then we can change this every time we run it. We can make it 2. We can make it 1. And now we're also passing in, here's that df.mean. We're passing in the variable instead of hard coding the field name. And we're putting it into a more complete statement. So it's a little bit more readable and a little bit more user-friendly. There you go. So I could change this to 2 and rerun it. And now I get my different values. You could also put this into a loop and have it do fields 1, 2, and 3 in a loop. What if you want to get your statistics for all of your columns? There is a .describe. So you could do df.describe. It will give you here, see how we were picking out mean, max, and min, just picking out our individual statistics that we wanted to retrieve. The describe will get all of them for you. And if you do describe like this, it will get all of the stats for all of the columns at once. So what we're looking at is not the original table, but it's the statistics for each column. So notice for session 2, which is up here, our mean was 1.22, and there it is, 1.22. Let's say you only want the statistics for one column. You can do that by doing df, and notice how up here, we called our field in square brackets as a string, same thing. So we could do df, square brackets, field name, whatever that is. And then we can call .describe on that one field. Great. Let's move on to doing a little bit of math on the values in our table. Let's go back up to look at the table itself. Here we have the total precipitation for each session, but what if we wanted the average? What if we wanted to take 23.94 and 38 and average them into a new column? We can do that pretty easily by just pointing to each column, literally adding them up and dividing by 3. So that's how we're going to do it in this case. In terms of how to point to the columns, you can make variables that represent the column name as a string. Or in this case, you can dynamically get the field name using df.columns and then calling the index number. So by saying df.columns index 3, what it's saying is we are getting 0, 1, 2, 3. We're getting session 1. Really, all you need to do is point to each column using that field name or the variable for that field name. And the way you can output it to a new field is to just dynamically, on the fly right here, name a new field. So what this line of code is saying is take my data frame, basically make a new field called average precip, and set the value in that field equal to the value for that row from the first column, the second column, the third column, and then divide by 3. So running that will do it, but we can't really see anything. If you want to add a little bit of error checking into here, it's always nice to make it a little bit more user-friendly. So now we have a try statement. We have a statement saying, hey, we're calculating averages, and if anything went wrong, we can print out those error messages. All right, so now let's see if it actually updated. Does the table have a new column? Remember back to about 3 minutes ago when we were looking at columns. How can we print out the columns in the table? We did that up here. So let's grab that. Probably would have been quicker to type it by hand. All right, so now we can print out the columns in the table, and let's actually just run that. And notice how we do in fact have average precip in the column list. Now we are looking at this manually. Can you think of a better way to check if that field was created? If my emphasis on the word if got you, then you're probably thinking an if statement. So you could do if average precip, the name of the field that we called it, if average precip is in df.columns, then you could print out a statement. Field was created. Otherwise, print out a different statement. Field not created. And there it is, a field was created. Great. Now let's return the data again with df.head, just so we can kind of prove to ourselves that it was actually made. In df.head, if you leave it blank, it will just give you 5 rows, but you can type a number in there and then it'll give you that many rows. Let's run that. The great thing about a notebook, you can just go back and fix it. I always forget my parentheses on my print statements. All right, so now we can see it and it's spilling over. See the backslash there? It's spilling over here, and the average precip was not only created, but it has values in it. And I'm going to assume they're correct. Once you do all this work in memory, you might want to save out your new table as an updated copy of the table. So for that, you can use df.to_CSV. In this case, what we're doing is grabbing the original file name from way up here. See how we have file? So there's my original file name. We're going to grab the original file name, take off the .csv, tack on an _updated, so we're renaming it basically. And then in this line of code, we are creating our new output. It's going to go into our path that we defined above, and then give it that new file name. So it ran, and there it is. And if we take a quick look, we can see there's my proof. It was updated, and I can even open it up and see the values. Great. So now you know the basics to working with pandas, how to read in a table, how to view the data, how to do a little bit of manipulations to the data. There is a lot more you can do with pandas. We will have a second video to get a little more sophisticated. But if you want to know a little more, there are some resources right here. And this Jupyter notebook will be linked in the comments. Thanks for watching and happy coding.